Because angles are circular in nature, we can end up with some inefficient directions. And that's how I like to think of coterminal angles. So let's see how we can turn an inefficient angle into a more efficient set of directions. As a reminder, we have 0 degrees over here in the positive x direction. And if I have this angle 1060, well, I also know that 0 degrees or 1 full revolution is only 360 degrees. So I have a little ways to go. So I've gone 360 degrees. I'm going to go another full revolution, and I've still only gone 720 degrees. So you can see the full revolutions here are just in multiples of 360. So the next one would be 1080, which is going to be more than my angle alpha here. So I'm going to go ahead and go, well, a little short of that. And so my angle is going to be 20 degrees short of 1080 or 3 full revolutions. So we can have these inefficient directions where we have to go around the block multiple times, or we can take out those extra revolutions. So I'm going to come up with a coterminal angle to alpha that is going to have the exact same location. It's going to end up in this same spot here. And the way I'm going to do that is I'm going to get rid of those extra revolutions. So I'll go ahead and call this angle beta, and it's going to be equal to 1060 degrees, our original angle alpha. And I'm going to get rid of all those extra revolutions. Well, we can see that we had 2 full revolutions before we got to our location. So I'm just going to subtract out 720 degrees from here. And in truth, you can just kind of guess this. And if you need to subtract out more, you can just do that later. It's not really a big deal. And when we do that, we're just going to end up with 340 degrees. Well, 340 degrees is in between 0 degrees and 360 degrees. So that doesn't have any extra revolutions. So what we're going to say here is that 340 degrees and 1060 degrees are coterminal. And so what that ends up meaning is that if I want to get to this location here, I can choose to go around the block a bunch of times and go 1060 degrees, or I can just go directly to 340 degrees. In addition, you might note that instead of going in the positive direction, in this particular case, it's actually more efficient to just go in the negative direction. Now, how far would that be? Well, I could just take this 340 degrees and subtract an additional revolution. So let's go ahead and come up with a third angle. I'll call this one theta, and we'll subtract 360 from it. So the most efficient way to get to this particular location would just be to travel 20 degrees in the negative direction. So we basically have a couple of options. I personally think that it is best to either get the angle in between 0 and 360 degrees, or in between negative 360 degrees and 0 degrees. And the reason for that is I don't want to have to count extra revolutions. I want to efficiently get to my location. So let's look at one additional example and see if we can kind of formalize this algebraically. With our new angle, we have negative 3070 degrees, so that's obviously overshooting things in the negative direction. I don't want to have to go around the block multiple times, so I'm going to go ahead and just see if I can get rid of some of those extra revolutions. So as we mentioned before, if I just take my original angle and add a certain number of revolutions, so a number of revolutions where n is just a member of the integers, so it can be positive or negative, but it is going to be a full revolution, then I know that I'll be at the same location because I'm just taking out those original trips around the block. Well, one full revolution is 360 degrees. So I'm just going to multiply 360 degrees times n number of revolutions. And from there, I can really just kind of guess. So first, I'm gonna just pick a number that I know is really easy to multiply by, and that would be 10. And so I'm adding 10 full revolutions to this, and that's just gonna leave me with 530 degrees. Well, unfortunately, that's not in between 0 and 360 like I wanted it to be, but it's much closer. So I'm gonna do one more step, and I'm gonna take that angle, 530 degrees, which I already know is coterminal with my original angle, theta, and I'm going to subtract 1 full revolution, or if you want to think about it in another way, I'm gonna go 1 revolution in the negative direction. And that's going to get me to 170 degrees. Well, that's in between 0 and 360 degrees, so I know it's just one, I'm not doing any additional revolutions, and I can graph that pretty easily. Well, I know that it's just a little bit less than 180 degrees, 10 degrees less, and so I'm gonna get pretty close to 180 degrees, and that will be 170 degrees, which is going to have the same location as my original angle, negative 3070 degrees. I will say they are technically different angles, but in reality, there are very few situations where it's actually going to matter. When you look at coterminal angles, look at it as almost a shortcut to the location you're trying to get to. And since an angle is predominantly about getting to a specific location, you don't want to have to go around the block multiple times. So work on that mental arithmetic and using those poles, 0, 90, 180, and 270 as kind of footholds to then find the location of your angle more efficiently.